Welcome to your 8th grade virtual classroom with Mrs. Gutenberg.
Hey guys, I hope you're staying safe and healthy. I just wanted to review some things from this week on pedigrees, which is basically like a family tree, but it shows your genetics. So hopefully you haven't forgotten all that you learned with genetics before we left. So I just want to show you my computer screen. So this is what you should be seeing. So you should have done an ed puzzle on pedigrees. And then if you click on this helpful chart, it shows you what all of the symbols that go with pedigrees mean. And before you all left, I gave you a packet that looks something like this. It's the same thing. If you don't have it, it's not a big deal. I just filled mine out, but what you're seeing on the link is the same exact thing. So if you don't have your packet, it's not a huge deal. So you should have reviewed those things. And then you were supposed to complete the quizzes over pedigree. Can you show my screen again? So this would have helped you to review what all the symbols mean. So I'm not going to go through all of them, but basically you found out that squares are males and circles are females. So females tend to be a little bit more curvy than males. Males are more square in their build. If it's shaded in, it means they're affected. They have the trait that we're looking for, whether that's a dominant trait or a recessive trait. If they're connected by a line, they're married. And if they have a bracket, anybody off of them is their child. And then if they're half shaded in, they're a carrier male, which means they carry the trait, but they don't show it. And same thing with the females. If they're half shaded in, they carry it, but they don't show it. And then obviously if they aren't shaded in, they do not have the trait that we're looking for. All right, so that is where you should be. Can you zoom back in on my screen? So step 4 says complete the pedigree student journal assignment on Unified Classroom. So hopefully you're able to find that. If not, send me an email, but it's basically the packet that I gave you before you left, but it's in Google Doc form, so you can actually type right into that. So I'm gonna pull it up here. I'm gonna work off my hard copy of the paper so that you can kind of see, but I'm gonna do the first 2 examples together. So, all right. So here it is. So again, this is what you're gonna see on your Google Doc. Mine just looks a little bit different because it's the hard copy that I gave you before you left. So in humans, albinism is a recessive trait. The disorder causes a lack of pigment in the skin and hair, making an albino appear very pale with white hair and pale blue eyes. This disorder also occurs in animals. A common albino found in a laboratory is the white rat. The pedigrees below trace the inheritance of the allele. Remember, the alleles are the letters that causes albinism. So remember, albinism is recessive, which if you remember means you have to have 2 of the letters to show albinism. So I'm gonna skip past the pedigree for a second and answer the first couple of questions. So number 1 says, given the following genotypes, remember genotypes are your genes, describe the phenotypes, remember phenotypes are your physical traits. So what do you look like physically? So is it gonna be normal or albino? So this is all from before break. So if I'm big A, right? My recessive is little a. So this guy's gonna be normal. If I'm big A, little a, it's gonna be normal. And if I'm little a, I'm gonna be albino. So remember, little a is recessive. I have to have 2 of them. So now we're just gonna kind of look at the overall pedigree. So number 2, how many children does this family have? They should have 3 children. So this indicates that they have children, and there's 3 of them. What are the sexes of the children? So they are all females because they're all circles. And then it says, how many individuals in this family are affected with albinism? There's only 1 completely shaded in. So, there's 1 child, and then the dad also has albinism. So there's 2 that have albinism. And then what are the genotypes of each individual? So this is what you're usually going to have to do with a pedigree. So we know the genotypes of 1 and 5 for sure because they're albino. So they have to be little a, little a, little a, little a. Okay, now 2 is the mom. Since she has a child that's albino, she had to pass a little a to this child, but she doesn't show the traits. So her genotype has to be big A, little a. Okay, so I'll write those up here to help you out. And then children 3 and 4, they could only have gotten a little a from their dad, and then they didn't get a little a from their mom, or they would be albino, so they had to get the big A. So 3 and 4 are both big A, little a. So I'll just write their genotypes in there. Okay, so remember they get 1 from the mom, 1 from the dad. These guys don't have albinism, so they could only get a little a from the dad, and so they had to get the big A from the mom. If they got her little a, remember they would show albinism. How did we figure out the genotype of the mother? Well, she has a child that's albino, so she had to have a little a. Okay, and then the one thing that this is missing is it didn't half shade anybody that carries the gene. So it says, using the key in your student guide, shade in the individuals on the pedigree above who carry the albino gene. So the mother would be a carrier. She carries the gene for it, but she doesn't show it because remember, this is called heterozygous, and if she was going to be albino, she would have to have 2 little a's. Okay, all right, so let's do this one. How many children does this family have? So here's the mom and dad. They have 1, 2, 3 children. If you wanted to count by marriage, you could say 4, but children, they had 3. How many grandchildren? So this is the mom and dad. These are their kids, and then they have 1 grandchild. How many individuals in this family are affected with albinism? So that would be anybody that's completely shaded in. So that's 3. And then what are the genotypes of each individual? So obviously we know 2, 3, and 7. They have to be little a, little a. Oops. Okay, so I'll write those in here. Okay, this dad does not have albinism, but yet he had a child with it, so he has to have a little a, but he doesn't show it, so he's going to be big A, little a. Okay, all of these kids, 4 and 5, they had to get a little a from the mom, but they don't show albinism, so they had to get the big A from the dad. And then individual 6 had a child with albinism. So let me write. So 5 would have had to pass the little a, and the mom would also have to be big A, little a. So hopefully that helps you out a little bit. I'm going to post the answer key to all of this. And if you have questions, I'll be available Tuesday and Thursday from 2 to 3. Just log on to my Zoom account. So again, I hope this is making some sense. Watch the Ed Puzzle. If you didn't watch the Ed Puzzle before you watched me, you probably don't know what's going on. So make sure you watch the Ed Puzzle, and hopefully this will help out. So if I go back to my screen here, you need to complete what we just started together on Unified Classroom. There's a second set of pedigree practice. I just want you to complete it on paper. Just write your answers down on a scrap piece of paper, or you can do it in a Google Doc. Unless you have a printer at home, you're more than welcome to print it. But I'll click on it real quick and open it up. So it's just another pedigree, and it's tracing dimples. So you'll complete that. And then when you are ready, there is a quiz. It's going to be found on Quizzes. I haven't made it yet as I'm recording this video, but it will be made for you. You just need to take that by Friday, April 3rd. So again, I hope you've learned a lot about pedigrees this week, and we'll see you later.
Make sure to wash your hands and stay safe. This concludes our session with Mrs. Gutenberg.